Okay, so ways to prove that something is a parallelogram. The first way to prove that something is a parallelogram is to show that both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. Okay. That's way number one. Shows both pairs of opposite sides are parallel. So I would show that this side is parallel to this side, and I would show that this side is parallel to this side. Okay. Bless you. And this is just the definition of a parallelogram. Okay, if you see that two pairs of opposite sides are parallel, then by definition it's a parallelogram. Okay. The next way is to show that both pairs of opposite sides are congruent. Show that both pairs of opposite sides are congruent. So again, I'd be showing that this side is congruent to this side, and I'd be showing that this side is congruent to that side. Okay, and that's known as the parallelogram opposite sides converse. Okay, that's one of the vocabulary words that you filled out. The next way is to show that both pairs of opposite angles are congruent. Okay. Show that both pairs of opposite angles are congruent. Okay. So I would be showing that this angle is congruent to this opposite angle, and I'd be showing that this angle is congruent to this opposite angle. Okay. And that's known as the parallelogram opposite angles converse. The next way is to show that one pair of opposite sides are congruent and parallel. So I'll put show that one pair of opposite sides are congruent. Where do I want to write it? I'll write it over here. And parallel. Okay. So one pair of opposite sides are congruent. And we also proved that that same pair of opposite sides are parallel. Okay, so just one pair there. That's called the opposite sides parallel and congruent theorem. Okay, and then the very last way is to show that the diagonals bisect each other. So I'm going to say show that diagonals bisect each other. Okay. And that is called the parallelogram diagonals converse. Okay. And let's see, if the diagonals bisect each other, let's go ahead and draw in the diagonals. That would mean that this part of the diagonal is congruent to this part of the diagonal, and this part of the diagonal is congruent to this part of the diagonal. Alright, now just a couple things I want to point out. I want to point out how many pairs we're talking about here. Notice for the definition we have to show that both pairs are parallel. For the next one, we have to show that both pairs of opposite sides are congruent. Here we have to show that both pairs of opposite angles are congruent. And then look at this one. Show that one pair of opposite sides are congruent and parallel. That's the only one where we only see one pair. Okay? And then this one we're showing that the diagonals bisect each other. So just pointing that out. Another thing I want to say is that I will never expect you in a blank proof to name all of these theorems. Okay, so unless you have a word bank to choose from, you won't have to pull these theorems out of thin air. You would just have to be able to describe it. Like I would say, like, oh, both pairs of opposite sides are congruent. That's what would be my reason. Like I would just explain it in my reason rather than having to say that it's the parallelogram opposite sides converse. You won't have to just pull those theorem names out of thin air. You just have to be able to explain why something's a parallelogram. Okay. Now down here at the bottom, it says, given that it's a parallelogram, fill in the missing information. Okay, so let's go through and complete these statements based on the diagram. So what would AB be congruent to? What would AB be congruent to? CD or DC, whatever one you want to name it, doesn't matter to me. I'm going to just name it DC. Okay, and then what would AD be congruent to? BC or CB, either one. I'll put BC. Okay? And the reason that I would put for that is that opposite sides are congruent. Opposite sides are congruent. Okay? Notice that I could have made you put opposite sides converse, but again, if there's no answer bank available, you just have to be able to explain the reason rather than name the actual theorem. Okay? All right. Angle A would be congruent to what? Angle A would be congruent to angle C, and then what would angle D be congruent to? C. Okay, so I'm going to put that A is congruent to angle C, and D is congruent to angle B, and it's because they're opposite angles, right? So I'm going to put opposite angles are congruent. All right. Then we're going to list the parallel sides for AB and AD. So let's go over here. What side is parallel to AB? DC, right? And what side is parallel to AD? BC. Okay. So I'll go back over here and I'll fill that out. So you can see I put that AB was parallel to DC and AD was parallel to BC. And when I explain it, I'm just going to say opposite sides are parallel. Okay. And all of these conclusions I can make, the reason why I can make these conclusions is because it told us that it was a parallelogram. So see how I'm using all of those parallelogram properties? Okay, that's only because I was given that it was a parallelogram. All right, it says angle A is supplementary to blank and blank, and angle C is supplementary to blank and blank. So let's start with A. What two angles would A be supplementary to? A would be supplementary to B, because they're consecutive, and A would be supplementary to D, because they're consecutive. Yep. So let's go back over here. So I'd have A is supplementary to angle B and angle D. And C, what would C be supplementary to? B and D. Did I do that right? A is supplementary to B and D. Yep, and C is supplementary to B and D. Okay, and that's because they're consecutive angles, right? Consecutive angles are supplementary. Okay. Then it says draw AC and BD. The lines intersect at E. So I'm going to go over to my picture here and I'm going to draw in those line segments. So I'm going to draw a line segment AC, and I'm going to draw a line segment BD, and I'm going to make them intersect at E. Now what reason could I make for that? That's kind of a weird reason. you see that it just says 2 points make a line. So basically we just connected the 2 points, right? And any 2 points make a line. Okay, fill that in. That one was kind of weird. Angle BAC would be congruent to what? Angle BAC would be congruent to what angle? What would be the alternate interior angle of BAC? DCA, right? This angle right here, which my diagonal wasn't very good the way I drew that in. Okay, but those would be alternate interior angles. So I would say that BAC is congruent to DCA. Okay, and then what would be the alternate interior angle of DAC? DAC would be congruent to BCA. Very good. Angle BCA. Okay. That is the alternate interior angle theorem. Right? Because the lines were parallel, we could say that the alternate interior angles were congruent. Okay. The last part down here is asking for what AE is congruent to and what DE is congruent to. So let's go to our picture. What would AE be congruent to? EC. Okay. And what would DE be congruent to? EB, right? Or BE, whatever you want to name it. Okay, so AE, I said, was congruent to CE, or you could call it EC. And DE was congruent to BE, or you could call it EB. So you could do either one. Right? And that's because the diagonals bisect each other for a parallelogram. Diagonals bisect each other. Any questions about how to fill out the statements or the reasons there? Okay. All right. So let's go ahead and flip this open to the next page. We're going to actually get into proofs now. We're going to be proving some things. So notice that we are given that the shape is a parallelogram. As soon as I know it's a parallelogram, what do I know? What are some things that I know as soon as I'm given it's a parallelogram? Sure, opposite sides are congruent and parallel. We have opposite angles are congruent, right? We've got that diagonals bisect each other. We automatically know all of these things. We also know that DE is congruent to FB. So I'm going to just mark that in the diagram that DE and FB are the same length. Okay. And ultimately, what am I trying to prove here? I'm trying to prove that angle 1 is congruent to angle 2. Okay. So I'm trying to prove that this angle is congruent to this angle. The way I'm going to go about doing that is I'm going to prove that these outer triangles right here, I'm going to prove that they're congruent triangles using one of our triangle congruence properties. And then I'm going to use the corresponding parts of congruent triangles congruent to show that those side lengths would be congruent. That's like where we're headed. So in that vocabulary review, that's why part of the vocab review was reviewing SAS, AAS, HL, all of those triangle congruence properties. Okay, let's go ahead and set up our statements and our reasons. Okay, and what's always my first statement? Given. Okay, so my first statement, I'm going to put that ABCD is a parallelogram. And I'm going to put a comma and then put that DE is congruent to FB. Okay, so all that was my given. Okay. I also know that ABCD is a parallelogram. So this whole thing, this shape on the outside here, this whole thing is a parallelogram. So tell me something I know about what D, angle D, would be congruent to. Kaylin? Angle B. The reason why I'm picking those angles is because see how those are also angles in these smaller triangles? So I can label that D is congruent to angle B, this angle down here. Okay. So you can see now I have S and A of each triangle. Okay, so I'm going to put in my proof. Step 2 is that angle D is congruent to angle B. And my reason, I would accept two things. You could either put that opposite, you could put the reason that opposite angles are congruent, and then put in the parentheses that that's a parallelogram property. Or you could just say what the theorem is. So we had said that that was the parallelogram opposite angles converse. Okay, you could use that as well. Okay, but like I said, I'm not expecting you to pull that parallelogram opposite angles converse just out of your head. So if you just want to explain that it's a parallelogram property, that's sufficient. Okay. So now I've got SA. What else would I need to know in order to use a triangle congruence statement? It'd be nice if I had another S, right? Because then I would have SAS. What would segment AD be congruent to? CB, because it's a parallelogram, right? Opposite sides of a parallelogram should be congruent. So I'm going to come back over here to my statement, and I'm going to put in for step 3 that segment DA, or AD, is congruent to segment BC, or you could put CB. And that's because opposite sides are congruent. Okay, and again, that's a parallelogram property. Okay. And now that I have SAS, I can say that those two triangles are congruent. Okay, so my next step of my proof, step 4, is going to be saying that triangle AED is congruent to what triangle? Remember, we need to match up corresponding parts. So what part of this triangle down here corresponds with A? A would correspond with C. I agree with that. Okay, and then E would correspond to what part? F, right? And then we would go to B. And so that would be by the SAS congruence theorem. And now that we know that these triangles are congruent, what's true about all their corresponding parts? They're also congruent, right? So now I can say my last statement that angle 1 would be congruent to angle 2, which is this guy right here and this guy right here. And see how those are corresponding parts? Those corresponding parts of those triangles should be congruent. So that's where I'm going to use that CPCTC. Okay, which is another reason, again, why I put that in the vocabulary review. That was one of the matching questions you did. Okay. Any questions on that? Okay. So part B is similar. We're still given that it's a parallelogram. So notice we have all of those parallelogram properties that we can use. I'm going to set up my statements and reasons. I'm going to put my given first. I'm going to put that ABCD is a parallelogram. And that's my given. Okay. And I'm trying to prove what? Let's look at what we're trying to prove. We're trying to prove that AEB, this triangle, is congruent to CED, this top triangle. So I'm just trying to brainstorm here. Right now I see that we have vertical angles, right? So I could use that. I also know it's a parallelogram, so I know that opposite sides are congruent. What's another parallelogram property we could use? We could also use let's see, diagonals bisect each other, right? So like this part would be congruent to this part, and this part would be congruent to this part. Okay, so really I'm looking at this also thinking that the diagonals could bisect each other. So when I'm proving this, I'm thinking that we could use really SSS because we could use diagonals bisect each other and we have opposite sides that are congruent. Another option we would have would be SAS because we could use that these diagonals are the same, these parts of the diagonals are the same, and we have vertical angles, right? So we have a couple different options. You could either do SSS or SAS. I'll go ahead and do SAS just since it's a good review of the vertical angles property. Okay, but you really have two options here. So I'm going to put for step 2 that we're going to talk about the diagonals bisecting each other. So I'm going to put that DE is congruent to BE. And I'm also going to put that AE is congruent to CE. Okay, and that's just because the diagonals bisect each other. Diagonals bisect each other, which is a parallelogram property. Okay. So I've got this is congruent to this, I've got that's congruent to that, and in order to do SAS, all I need is that included angle. So I'll put this angle and this angle are congruent because they're vertical to each other. So I'll put angle DEC is congruent to angle, we'll call it, let's see, DEC, we'll call it BEA. And that's by the vertical angle congruence theorem. Okay, and now we have enough to say that the triangles are congruent. So now I can name the triangles. It told me exactly how to name them. AEB is congruent to CED by SAS. Any questions about those? Like I said, if you wanted to do SSS, you could do that as well since opposite sides would be congruent. Okay. All right, the last one is just a little bit different because notice that I'm not given that it's a parallelogram. Do you see how I'm not given that it's a parallelogram? I'm trying to prove that it's a parallelogram. That's going to be different because what that means is I can't use the parallelogram properties in my proof. Like I don't know right now that opposite sides are congruent. I don't know that opposite angles are congruent. Okay, you can't assume that. That's what we're trying to prove. So it's a little bit different. Okay. So let's look at what we are given. We're given that DB bisects AC. So this segment DB bisects AC. So I know that it splits it into 2 equal parts. Okay, so that should be part of my proof. I also know that angle 1 is congruent to angle 2. That's what I'm given. Okay, so we are given that it's bisected, and we're given that angle 1 is congruent to angle 2. Okay, so let's go ahead and start our proof, and then we're going to start trying to figure out how we can prove it's a parallelogram. So I'll set up my statements and my reasons. Okay, the first thing I'm going to put is just the given, as always. So for step 1, I'll put that DB bisects AC. And I'm going to put that angle 1 is congruent to angle 2. Okay, that all is just given information. Okay. What did this word bisects tell us? Like, what could I draw in my picture from that word, bisects? Yeah, it splits it into 2 equal parts, right? So I could say that AE was the same length as EC. That's going to be the next step of my proof. Okay, so I'm going to say that segment AE was congruent to segment CE. And I'm going to say the reason why I could say that was because of that word bisect. Definition of segment bisector. Okay. Again, in the vocabulary review that you did, I had you match up the definition of segment bisector, okay, with its description. Okay. All right, let's see, what else can I say about this picture? Oh, what else do I know? I don't know it's a parallelogram, so I can't say anything about the other alternate interior angles. I don't know that those lines are parallel. Can't imagine. So, okay, so CEB and DEA, these two angles right here, I do think that we could say something about those. What are those? What are those angles called? They're vertical angles, yeah. So I could say that those are congruent, absolutely. So what do we say, BEC and DEA? I'm looking now kind of at these triangles almost. Like, you see how we're starting to develop things about these triangles? We have an angle already, we have a side, and now we'll have another angle. Okay, so let's go ahead and put that in the proof. We know that DEA was congruent to angle BEC because those are vertical angles. So I'll put vertical angle congruence theorem. Okay. And really, like I said, over here we have now AS, and then we just found out these vertical angles. So we have ASA. Do you see that? How we have two angles and an included side. So this triangle would be congruent to this triangle. So these two shaded triangles, I'll shade them. Those two shaded triangles would be congruent, which is interesting. Okay, so let's go ahead and name those triangles. I'm going to put triangle, we'll call it triangle DEA is congruent to triangle BEC. And we said that that's because of ASA, two angles and included side. Okay, and now that I know that two triangles are congruent, what's true about all their corresponding parts? What's true about all the corresponding parts of a triangle once we show that it's congruent? Yeah. Yeah, absolutely. The corresponding parts are congruent. So look at what I already have. I already have that this diagonal is bisected, right? If I can prove now that this diagonal is bisected, right, because those are corresponding parts of those two triangles, what does that tell me about the whole shape? It's a parallelogram, right? That's one of our properties of parallelograms, that if I can show that those diagonals are being bisected, then that would be enough to say it's a parallelogram. Okay, so I'm going to say that these two parts are congruent by CPCTC, and then that allows me to show that the diagonals bisect each other. Okay, so I'm going to come back over here for step 5. I'm going to say that segment DE is congruent to segment BE. Right, and that's because corresponding parts of congruent triangles are congruent. Once I've got that, I know that AC bisects DB by definition of a segment bisector. And then my last step is to say that it's a parallelogram. ABCD is I'm just going to draw a parallelogram. It's a parallelogram, and that's because the diagonals bisect each other. Which is a parallelogram property, right? Parallelogram property. You don't have to put parallelogram property, but that's one of our ones on the front page. Right? Really, to show that something's a parallelogram, you have to show one of these 5 things. You have to, right, to prove something's a parallelogram, you have to show opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, opposite sides are congruent and parallel, or the diagonals bisect each other. So we were using option number 5 to prove that it was a parallelogram. Any questions about that? Okay. All right, that's where we're going to stop today. Your homework